Hello everyone, I decided to make hopefully quick tutorial about music theory from point of view of engineer. The reason why I decided to do this thing because mindset of engineer a little bit different than mindset of artist. Then I was learning about music. Some concept of music theory was hard for me to understand, and I want to share my understanding of music theory from my point of view as a software engineer. So the biggest thing for me was a misconception about music theory because I have also a degree of physics. The definition of theory from a physics perspective not aligned with the definition of theory in music. So music theory, essentially, it's not actually a theory, because the theory from scientist point of view, it's some construct, theoretical construct, which you can prove or disprove doing some experiments around it to prove or disprove the theory. So music theory is not this thing. Music theory is more like a language people can communicate with each other to understand different concepts in music. I think it's kind of similar as in biology. Biology also has a lot of terminology. I think it's kind of more like science of music because it's more about terminology describing the concept of music which are not existing outside of the music. Music theory is basically terminology around music. Music, it's something around sound. Let's talk about sound. What is the sound? Sound requires some medium. Usually it's air, and air is molecules very fast flying around. This is molecules. Then we are talking, or some musical instruments make sounds. What happens with molecules? They are getting compressed and then decompressed. And this compression and decompression propagates. We have source of sound somewhere here. Let's say it's a speaker, and there is a membrane here, and it's moving back and forth. And what it does, it's if it's moving this direction and there is air here, it's get compressed, and then there is a high pressure point here, and this high pressure point start propagating usually in like a circular fashion. And then this membrane moves our direction, this direction. Air here decompress, and low pressure starts also propagating around. We have microphone here, for example, or human ear here. Microphone detects changes in the air pressure. Sometimes it has similar membrane, and membrane is moving, and then it converts to voltage, and we can represent it as a graph. This can go in the computer or makes signals in our nerves and goes to the brain. This is the sound. The sound has multiple characteristics. Basically, this is the graph, and we are looking at the graph. It goes up and down. How high this range, this is called volume, how loud or quiet the sound. We can run spectral analysis of this sound, and we can convert this graph, in which is amplitude over the time, to the different graph, which is amplitude and frequency. It might be have like some sort of peaks, and this is the frequency. Sound can be tonal and atonal, and if it's tonal, it will have fundamental frequency and then harmonics on top of these things. Fundamental frequency, let's say it's a F0. Harmonics usually goes like 2 F0, 3 F0, and so on. So the lowest one called fundamental frequency, and on top of them they call overtones. You can call like a first overtone, second overtone. They have frequencies. And music, it's usually there is a lot of tonal signals and atonal. So tonal, it's like a piano sound, or atonal, it's a drum sound. Drums actually we can also tune, but usually we consider them as atonal. We have time. We can have different types of sound during the time, and each sound has its velocity, frequency if it's tonal, or it doesn't have frequency if it's atonal. Also, each harmonics also has its own amplitude, and the set of amplitude actually makes our brain to interpret what instrument is playing. So if it's one set, we hear it as a piano. If it's in our set, we hear it as a guitar, for example. This set of sounds in music, it's called notes, and notes have more kind of simplified characteristics. So notes, it has multiple characteristics: velocity, how loud is the note, then the representation of the frequency, it's actually called the note, and duration, how long note is playing. Velocity is less important in music theory. It's kind of more important in the classical music, but in modern music there is not too much attention to velocity, but it's here. Note, it has a direct correlation to the frequency, and duration, it's like how long note is playing. Also, there is rest notes, which means just no sound, not to play anything. And to represent all notes in the music, there is a music notation is used. You quite often did see it. It's 5 lines, and it has the symbol which saying where the note is located. You can see like these sort of notes. Quite often you see like these sort of notes or with these sort of things. Let's talk about how we convert frequency to the note, and like we have names for them like A, B, C, D, E, F, G. We have different names from solfeggio: do, re, mi, fa, sol, la, ti. It's basically saying what kind of frequency you have to play. And I want to start from Pythagoras, and it came from him and set up whole this Western way of understanding music. There is different stories. I heard at least couple, and he was playing with strings. It's one of the story. He plucked the string, and string start vibrating and making some noise, and then he got exactly the same string and cut it in half, plucked the string, and it's made sound. We understand the physics correctly with twice higher frequency. He plucked 2 strings, and he noticed this sound pleasing. And then he got the string and cut the string in third of the length of original string, pluck both of strings, and noticed it also sounds pleasing. And he start playing with all different type of ratios. So this is 1/2, so this 1/3. He made the assumption the sounds with simple ratios are sound pleasing for ears. This thing spawned the set of ratios. So from original frequency, and so like a 1/2, 1/3, 2/3, 4/5, and so on. We can put them in the line. Let's say this is the original frequency F0, and this is 2 times F0. In all these simple ratios in the line, and let's say, you understand, right? Like this one have a frequency F0, and if we cut the string twice, it will make the frequency 2 times F0, and if we cut the line 3 times, it will make 3 times F0. We can actually make the 2/3. It would be frequency corresponding to frequency 3/2 F0. 3/2 F0, and this one is a logarithmic. Let's make it a logarithmic scale, and it's somewhere here. It doesn't matter too much. 3/2. It's a second most pleasing combination. Anyways, he put all these ratios here on the line. It's made 7 notes essentially at the end of the day. 7 notes in the major scale, and then call them C, D, E, F, G, and A, B, and then 2 F0, it's a C, or do, re, mi, fa, sol, la, ti. The problem with this arrangement, on logarithmic scale, they are not evenly distributed. The reason is if you want to evenly distribute those notes on logarithmic scale, the ratios which you will get would become irrational numbers, and irrational numbers you cannot represent with the simple ratio, even with any kind of ratio. At some point, people decided to temper the music scale, what they did, they divided this scale evenly. It starts from F0, ends at 2 F0, we know this, and this one starts at frequency 1 times F0, and this one at frequency 2 times F0, and we want to evenly distribute all notes. Initially it was 7 notes, and later on another 5 notes were added. On piano you would see 7 white notes and 5 black notes. Do starts from here, 2 times higher frequency is here, and we see 1, 2, 3, 4, 5, 6, 7 white notes and 5, 1, 2, 3, 4, 5 black keys. We need to split this range in 12 evenly distributed notes. We have a sort of equation, F0 equals something, and we want to start from note, some sort of n times some coefficient. But if we would do this way, this is a linear progression, and it would not work very well, because next octave is, we want to be twice as higher with this note, and if we would do this way, this would be, this note is 0 note, right, and this one is 12, and this one is 24. It would not be 4F, it would be 12 times K, and this would be 24 times K. Oh, wait a second. So we need to start, if we want to do linear one, we need to start from 1, because 0 times K would give the 0 frequency. So 1, this one 13, and this one 25. We will have here 1, 13 times K, and this one 25 times K. And if we want this thing twice higher, K based on this logic should be 2 divided by 13. And if we use 2 divided by 13 here, we would get 25 times 2 divided by 13, which is 3.84, and we want to actually 4. So it doesn't work this way. We need to use logarithmic scale, and to do this thing, we need to have 2 in power of n times K. In this case, it would work. We need to figure out the K, and we can start from 0. Just for simplicity, we can start from any 12, 24. We can start from 0 at 0 and 0, 2 in power of, so it's F0 times 2 times n times K. So this is the formula. We start from 0, 2 in power of 0 is 1, so we've got F0, and here at 12, we want to be 2 times F0, F0 times 2 at 12 times K. So we want this thing to be 1. Essentially K is 1 divided by 12. 12 times 1 divided by 12 is 1. 2 in power of, times 2, 12 times 1 divided by 12. This one is cancelling. 2 in power of 1 is 2. So we've got 2 times F0. And for 24, we want to be F4 times F0. Let's verify if it's a case. 2 in power of 24 times 1 divided by 12. We are getting here F0 times 2 in power of 2, which is F0 times 4. For octaves, we are getting what we want. And all notes in the middle, let's get the 7th one, F7, 7 times 1 divided by 12, 7 divided by 12, 2 in power. And we've got this value, 1.498, 1.498. So we've got this value. This one is very close to 3/2, which is 1.5. And essentially people realized all notes are quite more or less close to simple ratios, which are Pythagoras discovered. So we decided to use equally tempered scale. We've got 12 notes. They are starting from, also we all decided to go with initial frequency is 440, which is note A, which is sound like this. I guess this one is 440. I don't know. We can generate it. Sounds like this. We're starting from this note, and then we are just using this formula to get all possible notes from here. We usually start from C, and there is a A here, and there is a B here. We have notes in between, initial notes A, B, C, D, E, F, G, A, B, C. And we have 5 notes in between also, maybe, and which are called sharps. So D sharp, F sharp, G sharp, and A sharp. This is 12 notes. We start from 440 here, and also we have A sharp here. We're figuring out frequencies using this formula, and 1 and 2 and so on. We can quickly do it. Maybe I'll do it in a spreadsheet. We start A sharp, B, C sharp, D sharp, E, F sharp, G sharp, A sharp, B, C. We start from A, which is 440, this note. To find next one, we need to use the formula, which is this guy times 2 power 2 and put 0, 1 here, and we use formula here. So this guy times power 2, this guy times 1 divided by 12, and we've got all these notes. We actually can verify A sharp is 466, and we can just in Audacity generate this tone, and we can hear it sounds same. Let's do something more interesting. I don't know, let's do F. Let's generate an Audacity F, which is this. And this one is F. It sounds same. Okay, this is how we are getting notes in our Western music. It's equally tempered, and we are going to thank Pythagoras to do this thing. There is now, you know, this is our Western music, and almost every modern music produced is using this system. This is also, I guess, good for you to understand we are in the system, and because art, it's about breaking rules. So you know what kind of rules now you can break to try to make a little bit different music. Let's go back to this thing. Beyond we have notes, and they called like this: C, D, E, F, G, A, B, and they have sharps. Also, they have flats. Sharp actually means go up to 1 semitone, and yeah, so distance from the smallest distance between notes, it's called semitone. 2 steps, it's called tone, or 1 step. It's a little bit, yeah, it's a little bit confusing. Going up from note, we're adding sharp, and if we want to go down, we're adding flats. We're going down from B, it's a B flat. Going down from D, it's a D flat, E flat, G flat, A flat, and B flat here. This symbol calls flat, this symbol calls sharp. So let's go back to this notation. This symbol tells us where is the specific note, and I believe it tells us where is the B note. So this thing shows like it's touching this line. It says note B is on this line. As you noticed, you can put note on the line and below the line, in between the lines. If you put the note here, it would be B note. If you go up, it will go B, C, D. We start from B here, and if you go up, it would make C, D, E. If you go down, it would be A, G, F. This one is B note. this one is C, this one is D, this one is F, and so on. So this one is A, G, F, and so on. One thing I want to mention, if you run out of the space, you can add additional lines. So you can do it like this. It would become C, F, E, D, and this one is C. And if you go over here, you also can add additional line like this. So it would be F, wait a second, it's a E, F, G, and this one is A. You can go higher, so like if you put here A, B, and this one is C. Placement on the staff represents the frequency of the note, and we need to also specify the duration of the note. To specify duration, we are splitting the music in bars, and to divide bars, we basically drawing like a vertical line, and each bar is one specified duration. And usually in music we just put like duration of the quarter note. Quarter note looks like this, and we can say like a 120 beats per minute, or actually 120. Quarter note is equal, so we have 120 quarter notes per minute. With what does it mean? And the whole bar, it's a whole note. It's like a 4 quarter notes. Let's talk about the duration, right? Whole note looks like this. So it's just a circle with empty inside whole note, which is 4 times quarter notes. We need half note, and half note looks like this. You can also put it upside down like this. This is the half note, which is 2 times quarter note. And of course we have quarter note, which looks like this, and also we can make it upside down. This is the quarter note. We can have 8 note, which has this wiggly thing next to it. I will not draw upside down, but you can draw upside down. And you can combine them also like this. This is 2 eighth notes, and it's 1/2 of the quarter note. And we can have 16th note, which has 2 wiggly lines, and we can combine them like this. And we can combine as much as we want, I think up to 4. And we need to draw like a second line here. So it's 2 lines here. And 16th line, it's 16th note, it's 1/4 of the quarter note. And we can have 32th note, which is 3 lines. And again, we can combine them. And we need to draw like a 3 lines like this, and it's 16th. There is another way to represent duration, because of course these durations are a little bit rigid, and sometimes we want to have different durations, and we can add the dot next to the note. For example, quarter note. So we put the dot next to it, which means make original duration 0.5 longer. This means it's a 1.5 times quarter note. And same thing, whole note, it's 1.5 as a whole note, which equals 1.5 times 4 times quarter note, which is 6 quarter notes. We can have dots, and we also can have triplets. There is 3 notes. Let's draw 3 eighth notes like this, and then there is a thing on top added like this, which says it's a triplets. It has slightly different duration. It's slightly faster than original one. It's by duration equals to 2 equals like a whole with 3 notes equals by 2 eighth notes. Each one equal 2/3 of 8 note. And you can have triplets not only for eighths, you can have triplets for quarter notes, which would be equal to quarter notes. And each quarter notes would be equal to 1/3 of quarter note. This is the note notation, and we can make the melody. And now you can convert back what you can see here to the melody, except we did not cover black note. To alter the note, we can add the symbol, which would be sharp or flat next to the note, and it will alter this thing. F sharp would become half tone, so this is F, and it would become half tone higher, or B flat would become half tone lower. if we will have another F in the same bar, it would apply to it, but on the next bar, the bar line basically cancels the alteration sign. Also, we can apply to whole music, and in this case we put them next to the key sign. So if we put it here, it means like for whole music, F sharp is applied to all notes here, even like here. So like if we play F here, we have to play F sharp, not F. The sequence of notes makes the melody. Let's make some simple example. Let's make some kids song, ABC alphabet song. 5 lines. 5 lines with sign which shows where is the B note. Then we need to put the signature, and signature is 2 numbers. 4/4 means 4 fourth notes. We can have 3/4 means 3 fourth notes. We can have 2/2 notes, which essentially same as a 4/4, but by duration. But musically, it's kind of gives you hint you are going to have 2 beats over measure rather than 4 beats over 1 measure. Sometimes people specifying the tempo, and in classic music there is Italian terms for tempo, but it's like if you're doing modern music, it's usually just specified by how many fourth notes you have over 1 minute. And BPM, beats per minute, essentially it's a number of fourth notes over 1 minute. 120 BPM means we have 120 fourth notes in 1 minute in 60 seconds, and it means 1 fourth note equals 60 seconds divided by 120 BPM, which is 1 divided by minute. It equals 1.5 second. 1 fourth note is 1.5 seconds if the tempo is 120 BPM. And then we can place notes. So do. This is a whole measure, right? Whole bar. We draw vertical line here, and then I would not have like a whole song, ABC song, but like we will put 1, 2, 3, 4, 5, 6, 7 notes and the bar here. There is no alteration signs here, so we play all white keys, and which is so do, sol, sol, la, la, sol. This is how we can read the melody, and if we will have some alteration signs, I don't know where I can put, let's put like a here. So it would mean instead of playing with B, we would play B flat. Oh, what? Oh, I messed up. Oops, it's not B. Anyways, I think you got the idea. Before messing up with the notes. Usually I'm not using these representations. Usually in my DAW I'm just using piano roll. I'm kind of not used to this view, but it's useful to be able to read what's going on here. And if you want to transfer some melody when you find on MuseChord to piano roll, now you would be able to do it. So this is the melody, and we discussed we have 7 white keys, which starts from C. You may notice the distance between those notes is not equal. Distance between C and D, it's 2 semitones. Distance between D and E is 2 semitones. Distance between E and F is 1 semitone. Between F and G is 2, 2, 2, 1. And this sequence is essentially representing the scale. If we play from C to C in this fashion, it will make the this sound, which is called major scale. Major scale is a sequence, starts from some arbitrary note. We start from C and goes 2 semitone, 2 semitone, 1 semitone, 2, 2, 2, 1, and it's called major scale. And we can start from any note. For example, we can start from D note, but we would do 2 semitones and then 2, 2. So instead of playing F, we would need to play F sharp, 2, 2, and then 1 semitone we play G, and then 3 times 2, 2, 2, and then C sharp, and back to D, right? So we play D, E, F sharp, G, A, B, C sharp, and D. It sounds same, but it's 2 semitones higher. And we can start from any notes, like from E, but if we apply this formula 2, 2, 1, 2, 2, 2, 1, it will make the major scale. Major scale is one of the most important in Western music. Essentially everything just revolves around major scale, and now you know, and you can break the rule and not to use major scale. You can try to use different formulas. So major scale is one of the most important things, and there is a minor scale, and minor scale is essentially the scale which you can make using all white notes, but instead of starting from C, you start from A, and in this case you can see from A to B it's a 2, and from B to C it's a 1, and then sequences repeats 2, 1, 2, 2, 1, 2, 2. Minor scale is 2, 1, 2, 2, 1, 2, 2. If I start from A, it would sound like this. So it sounds a little bit sadder, which is why it's a minor scale. In contrast, major scale sounds like this. Minor scale is less important in modern music, but there is a quite good amount of songs written in minor scale, and I believe in classical music minor scale was kind of dominant. I do not know, I'm not expert, so I will not say anything. So these two scales are most important in the music, but there is a plenty of different scales, and you can basically try to do all different types of permutations using the 12 notes. And actually I did it, and I kind of ran the program and made all these permutations. And I also search on the web and try to find the names for all these permutations, but essentially this is, you can find it on miko.global of different scales. So like all semitones, it's called chromatic scale, and sounds like this. And of course we can find the major scale, and it also has a different name. It's called wait a second, this is not right major scale. So we need 2 2 1 2 2 2 1, right? 2 2 1 2 2 2 1. Yeah, so this is the major scale, and it's also have different name. It's called Ionian mode, and we can find minor scale, which is 2 1 2 2 1 2 2 2. Yeah, and it also has billion names, but like it's called natural minor, melodic minor scale, and Ionian mode. There is of course plenty of scales do not have names, and there is a plenty of scales do have names, but I did not find the name to them. There is a kind of playing quite important role. It's different types of modes, and mode it's basically the scales which are based on the major scale, and this why this minor scale has the name of the mode, because it's based on the major scale. How we building the modes from major scale, we just basically starting from different note and seeing what the sequence of the tones or semitones here. For example, if we start from D, we will get 2 1 2 2 2 1 2, and which will create the mode. Let's see, 2 1 2 2 2 1 2, which will create the Dorian mode. There is 7 modes starting from C, D, E, F, G, A, and B. So 7 modes. So as we learn, D it's a Dorian mode, starting from D, which is 2 1 2 2 2 1 2. It's a Dorian mode. Major scale also has the name, which is I do not remember, but just for completeness, 2 2 2 1 2 2 2 2 1. Oh, wait a second. It's called Ionian mode. Oh, wait a second. It's not Ionian. Ionian mode. How to pronounce it?
Ionian mode.
Ionian mode. Okay. So this is Ionian mode, which is 2 2 2 1 2 2 2 1. Next one is 1 2 2 2 1 2 2. Dorian sounds like this. Ionian sounds like this, very familiar. So this is wait a second. This is Phrygian mode.
Phrygian mode.
Anyways, I don't think I will go through all these modes, but you get the idea. So there is a bunch of scales, and there is scales are modes. They have names like a Phrygian mode, Ionian mode, Dorian mode, Locrian mode.
Locrian mode.
And there is also scales which are coming from jazz or blues. For example, nanotonic blues scale, bebop Dorian scale. Oh yeah, and there is one more pentatonic scale. This is a major scale, which is 2 2 3 2 3 2 2 3 2 3 2 2 3 2 3. This is a major pentatonic scale. It has only 5 notes in the scale, and there is a minor pentatonic scale, which is 3 2 2 3 2, right? 3 2 2 3 2. Sounds sadder, and again it's a 5 notes only. There is another minor anyways, there is a plenty of scales, and you can play around with them and see how they sound like. You can try to invent your own scale and play around with it, but essentially you can try to make the melody, and major and minor scales are the most common scales in Western music. Let's talk about chords. Chord is 2 notes, 2 or more notes played simultaneously. If you play, for example, notes C, E, and G, it will make a C major chord. Sounds like this. So we can play 2 or 3 or 4 or 5 notes at the same time. It's called chord, and they have names. But first, I want to talk about distance between notes. We already were talking about semitones. Distance between notes, also all different distances have names. It's music theory. It's all about terminology. No distance called unison, and distance of 2 semitones is called seconds. Distance of 3 one called third. Distance of 4 one called fourth. 5 fifth. 6 sixth, and 7th 8 tones or octave. As you can see, it's based on major scale again, because we have notes in between: C sharp, D sharp, F sharp, G sharp, A sharp. We have notes in between. Second is 2 semitones. Third is 1 2 3 4 semitones. It's 0 2 4 5 7 9 11. We need names for 4 intervals in betweens. This called minor second. This called minor third. So there is a fourth. This has we can call it minor fifth, but nobody does this thing. It has a special name. It's called tritone. And tritone is because distance from here to here exactly 3 tones. 1 2 and 3. This is the tone. There is different names also for intervals. They sometimes, I think more often called augmented intervals, and if you lower it, it's called diminished interval, and if you raise it, it's called oh, wait a second, if you raise them, it's called augmented, and if you lower them, it's called diminished. So you can call this interval from C to D sharp as a third diminished interval, and if you raise second interval, or so this interval basically has two names, right? It's called it might be called second augmented or third diminished. So this interval is a tritone. This is the names of intervals. There is a more, so we can go above the octave, and they also have names. Also, you can give the names, the call lowered by half tone. You can also call them flat. So you can call them flat. So this one is minor third, or you can call this thing flat second, or you can call it minor. So usually these intervals, I do not know usually or not, but I like a this interval, I just call it half step or semitone, and this interval usually I call minor third. This one I always call tritone, and these intervals I'm not using very often naming them, but I don't think called like a minor or flat. They usually called diminished or augmented. I'm taking it back. Yeah, so you also can call them minor or major, I think, because I'm not using them very often, and basically I'm not talking too much to musicians. So yeah. Anyways, this one you can call sixth, minor sixth, or major fifth. This one you can call minor seventh or major sixth, and this one is octave. In music theory, all these intervals also divided by groups, consonant and dissonant. It's kind of arbitrary, but like at some point people realize, oh, I mean octave, I mean it's from Pythagoras, and he was like, oh, this sound is pleasing, it's consonant, and if it's this one doesn't sound good, it's dissonant. But in modern music we are not we are not discriminating intervals, so we are trying to use all of them, but just for sake of knowing things, there is a dissonant and consonant intervals, and of course octave, it's a consonant, and perfect fifth also consonant, and perfect fifth, fourth is consonant interval. So this thing is are the most, let's say, pleasing intervals. And then our group is kind of less pleasing sounding third intervals, less pleasing, and minor third is also, but it's still considered as a consonant intervals. So, and then sixth also considered as a consonant interval. And there is our intervals are dissonant interval. Everything else called dissonant. Second, minor second, and seventh, minor seventh. They are sounds a little bit more harsh, but they have some sort of its own character, and they have some its own beauty. They used in modern music as well. And there is of course tritone, which back in the day was considered as the most dissonant interval. You may notice some intervals you can build from bass note, from C to E, for example, from this C up to this E, so it will make a third interval. But you can build same interval kind of backward. We go to E by 1, 2, 3, 4 semitones, and we can go back from C by 4 semitones. It's from here 1, 2, wait, so 1, 2, 3, 4, right? 1, 2, 3, 4. From G sharp to C, it is same interval, third, major third, and if we drop the C octave lower, so it will make minor sixth, and this way it's called inversion because it sounds kind of similar, because C here and C here, it's octave and it's essentially same note. I mean, it's have exactly same name, it's just the difference in the octave. It's called inversion, bottom line. Inversion for third is minor sixth. Inversion for second, it's minor seventh, and so on. Just a note. The interesting thing, you can see a relation between fourth and fifth, because they are inversion to each other. Let's talk about intervals above octave. They called compound intervals. This one is ninth, so this one is ninth, 10th, 11th, and 13th. 9, 10, 11. This is 12th, sorry, 13th. So this is octave, this is ninth, this is 10th, this is 11th, this is 12th, and this is 13th. I mean, it's just math. And intervals also can be played sequentially. It's still called interval. So then you are actually playing together even two notes. They called chords, and there is like a power chords, which is interval of fifth or fourth. But usually it's more than two. They called chords. Three notes played simultaneously called triads. If we play C, E, G, it's called C major chord. Three notes, they each have name. The bottom note called root, note in between called third, and the third note is fifth. Distance between these notes is a third. It might be minor third or major third. So major chord starts from root, and then third is major third, fifth is minor third. Let's deconstruct. Let's look at the major chord, C major chord, and we can see this distance is major third and this distance is minor third. C, D, E, F. So C sharp, D sharp, F sharp, 1, 2, 3, 4. So this is a 4 semitones, it's a major third. 1, 2, 3, it's a 3 semitones, it's a minor third. So this is the major chord. There is a minor chord, and the minor chord would be also starting from C, E flat, G. This distance is minor and this distance is major. Again, let's look, D flat, E, E, F, G flat. It's a 1, 2, 3, minor third, 1, 2, 3, 4, major third. C major sounds like this, and C minor sounds like this. And of course we can build major and minor chord starting from any note. Just for practice, let's start from A and build the major chord starting from A. Major third from A, it's C sharp, and minor from C sharp, it's E. This is the major A chord, sounds like this. It's a major, and A minor would be, we start from A and then we do minor third, which is just a C, and major third is just a E, and it sounds like this. In traditional music, chords actually 3 different notes, starting from 3 different notes, but in modern music 2 notes also sometimes may consider as a chord, like 2 notes, root note and fifth or fourth playing together, they call power chord. So major chord and minor chords are one of the most used chords in the Western music. There is plenty of other types of chords, of course. You can construct triads using different intervals. So there is more chords with different names. One of them is diminished chord. Diminished chord constructed as root, of course. Then third is going to be minor third, and fifth is also minor third. It's called diminished chord. Let's construct from, let's do D maybe. From D, minor third from D is F, and minor third from F is A flat or G sharp. It's the same note. So it sounds like this. This is diminished chord. So we have also augmented chord, which is major chord with raised fifth. It's called augmented. So it has a root. So augmented chord. It has a root. Third one is major third, and fifth one is raised. So it's also major third. So let's construct augmented from I don't know what we want, from E. Major third from E is G sharp, and then major third from G sharp is B sharp, which is the same as C. It sounds like this. Major E sounds like this, and augmented E sounds like this. This is augmented. Then there is suspended chords. So there is two types of suspended chords, suspended 2 or suspended 4. And the idea for a suspended chord is third is substituted by second or fourth. So in the suspended 2, third is substituted by second, and in suspend 4, third substituted by fourth. The formula for this thing, it has a root, and then it has second interval, and then it has perfect fifth, and here's the root, fourth, and then perfect fifth. So let's construct a suspended from C, for example. A second is going to be D, and fifth is going to be G. And same, let's construct suspended for sus4. It's going to be F and G. sus2 sounds like this, and sus4 sounds like this. sus2, sus4. sus2, sus4. And major sounds like this. Major, C, C major, and C minor sounds like this. sus2, sus4. And let's go to seventh chords. Seventh chords are not triads. They made out of 4 notes, and they called seventh because it has added seventh note on top of triad. Have major seventh, which has a root, then third, then fifth, and it has seventh from the root. And it sounds like this. Let's do from E. E, and then G sharp, then B, and D sharp. So it sounds like this. This is major seventh. Yeah, major seventh. Then we can have minor seventh. So it's a minor chord with minor seventh on top. So it has root, minor third, fifth, and minor seventh. Let's do same thing with E. So it's a E, G, B, and D. So there is a dominant 7. So it's a major with minor 7th on top. So it starts from root, 3rd, 5th, minor 7th. Let's construct it from F. It's a F, A, C, and E flat. And now we are, I think, going to the land of half diminished seventh, which is a diminished triads with minor seventh on top. So it's a root, minor third, minor diminished fifth, and minor seventh. Let's construct from B because it's gonna look nice. So B, D, F, and A flat or G sharp. So, and it sounds like, oh wait a second, I goofed. No. Yeah, because it's a A, so it looks like this. And there is a last one, diminished seventh, which is root, minor third, diminished fifth, and there is a seventh, which is lowered twice. Essentially, it's a sixth, but it's like a double minor, double diminished seventh. So let's construct it from C. C, E flat, G flat, and it's a B double flat, which is actually A. This chord is quite interesting because if we look at the keyboard and construct this chord, all these intervals are 1, 2, 3, 3 semitones, 3, 3, 3, and then if we go back to note C, it's also 3 semitones. It goes basically in this circle, which quite interesting property. In music we can use this property in interesting way, because this chord, if we listen for it, it has some tension, right? It's not a resolved chord, so we want to go somewhere from it. So for example to E major, and because for this arrangement we can pick like any root, like a C, E flat, G flat, or A. Any root we can build a chord, for example, from E flat. Oh, wait a second. So it's built from E flat. There is 4 different combinations, and then we can resolve from it like a 1 semitone higher, and like from here we can resolve 1 semitone higher, or from here we can resolve 1 semitone higher. So it's an interesting way to change the key in your music. So yeah, you can use it in your music creation. Essentially you have 3 types of different chords, so it can start from C, C sharp, or so 3 types: C, C sharp, or D. You can have only 3 types of this sort of chords, but it adds variety in your music. You can quite easily change the key from 1 to another using this chord. So let's talk about chord voicing. I was always mentioning that we have a root and we can have these stack notes on top of the root. Voicing essentially means we are putting notes of the chord in different places. We can put like a third at the bottom, or fifth at the bottom, or seventh at the bottom, or we can spread them differently. So there is all different types of combinations, and it sounds kind of similar but may add or remove something from the sound of the chord, and it's good to know to be able to experiment with the voicing of the chords, not just playing like a triad, but you can double some notes. For example, I'm playing right now G major, and I can add at the bottom in our G, right? Or I can add G and fifth. So I'm playing right now G, so I'm playing G here, and then I can put fifth on top of it, then play G and put third on top of it. So it's essentially same chord with different voicing, and it sounds more it sounds same as just a triad, but it's more kind of spread and have like a wider sound. So you can experiment with it, especially then you have 7th chord, so you can try to experiment. So like it's the same chord, but 7th is played like a below G, so 7th on the bottom, so it has a little bit different sound, so you can experiment with it. So it's the same chord but different voicing. Let's talk about terminology. If root note of the chord at very bottom, the chord called in the root position, G major, so G is at the bottom, so it's in the chord in the root position. If any other notes at the very bottom, not the root, the chord called inverted. So I moved G octave higher, so now is B very low at very bottom. So this chord is still G major but inverted. There is a degrees of inversion. If third at very bottom, it's called first inversion. If fifth at very bottom, it's called the second inversion. This is root position, first inversion, and second inversion. Then you are building chord in your music. Sometimes it's more interesting to raise the third octave higher. So for example, I have C major, right? It's more interesting to play it like this, because root and fifth are quite very consonant sound, and third is kind of gives the character to your chord. And anyways, so it's, you can play around with this thing, but like this combination have a little bit more meat than just a triad. So it's, this one sounds a little bit simpler, and this have like a little bit of more something in it. And yeah, so we talked about triads, we talked about 7th, and there is more chords, of course. We can add more notes on top. We can have 3 notes, we can have 4 notes, and we can have 5 notes, or 6 notes, or even 7 notes. Okay, we can add more notes. We can have 5 notes on top in the chord. 5 notes in the chord. It's called 9th. It's root, 3rd, 5th, 7th, and 9th. This can be 11th chord, which is root, 3rd, 5th, 7th, 9th, and 11th. And it can be 13th chord, which is root, 3rd, 5th, 7th, 9th, 11th, and 13th. Of course, it can have all these different modifications, which is dominant, half diminished, minor, major, which is have some names, but I guess it's just important to know they do exist and they can be used in making your music. You can just play around and listen how they do sound. So this is the 9th, for example, and you can play around with voicings. ninth. So you can play around with all these chords and see how it sounds and how you can use in your repertoire. But TLDR, major and minor chords are most used chords in music. Major and minor. Seventh chords are used also quite extensively, and ninth, 11th, and third less, but you still can play around with them. We were talking about adding notes to the chord. We start from triad, then we talk about 4 notes chord, 7th chord, and then we can have 9th, 11th, and 13th chords. We talk about inversions, and basically we're just talking about all different types of permutations, how we can stack n numbers of sounds, and what kind of names they do have. And there is one more way to play around with chords. It's removing the note from the chord. And if we remove the note from the chord, it's called partial chord. And basically from the partial chord, you can remove 3rd or 5th. And if you have like a 7th chord, for example, you can remove the 3rd, and it will have only root note, 5th, and 7th note. So for example, we can have C major, 7th, and if we remove 3rd, it would sound like this. So what does it mean? Removing actually sometimes is adding. So this is the 7th, and then this is the 7th major C major without 3rd. It sounds different, and it's actually adds something to the sound. Even we removed actually the note. Keep in mind, removing something also can add something to your music. And yeah, and if you remove the sound from the chord, it's called partial chord. In music theory, there is so we talk about melody, which is just a sequence of notes with a certain duration for each note. We talked about chords, and we can have a sequence of chords also, which will create the harmony of the melody. The whole, in Western music, the whole song, the whole music piece usually have a key. Sometimes, and it's quite often, it's have multiple sections with different keys. And this one is kind of not well defined, so there is a lot of debates, or this song is in this key, this song is in this key. This is not quite defined, like what does it mean the song is in the key. And usually piece starts with the key chord, so like if it starts with C major, usually it's C major, or usually also it's ends with this chord, and usually melody ends on the root note of the chord, so it's you can kind of figure out the key. But yeah, there is a thing which called the key, which means like you're basically feeling how it's like where is the piece is rooted, but it's not well defined. We can have chords and melody combined together, and usually like one chord takes 1 bar or 2 bars. Like it's like a slow changing sequence, and melody is a little bit faster, and it has more rhythm in it. Changing chords have like a common sequences. In the major key, there is 3 chords are the most important chords. So if we have music in the C major key, there is a chord based on the C major key, which is C, E, G, and then there is our chord which is on the 5th from the C, which is G, B, and D. This is the C major, then G major. And usually chords have just a number, so this one is 1 and this one is 5 because it's a 5th note in the major scale. And there is one more chord, it's 4th, which is F, A, and C. These 3 chords are kind of pillars, and then you can play around these free chords. And basically quite a lot of music you can just kind of put in these free chords, and they would be sounding okay. So I used only these free chords to play the melody. So sequence of chords, it's called a chord progression, and usually it uses numeric system because key is not very important. So 1, 5 and 4, and in C major it's a C major, G major and F major, but in D major it would be D major, A major and G major, right? So it's D, F sharp, A, C sharp, E and G, B, D. And it's the same 1, 5 and 4, and we have quite a number of chord progressions. Let's talk about our chords in the major key. So this one is the most important chords, but we have a second, a third of course, and then sixth, and then we have seventh, but it is diminished chord, and it's like I put like a lowercase for them because they are minor in major key. This one is D, F, A, this is E, G, B, and this one is A, C, E, and this one is B, D and F. These chords are minor chords because D between F is 3 semitones, E between G it's 3, it's 3 semitones, it's a minor chords. And last one is diminished chord. We have common chord progressions. I did some research and find a list of the kind of common chord progressions. So it's like a 1, 4, 5, 7. It's not like a comprehensive list, but it's like a this is very common chord progression. Played 1, 4, 5, 7th, and actually it's a 7th minor 7th, and then go back to 1. So 1, 5, 7th, so it's a minor as you can hear, and 4, and then back to 1, 5, 7, 4, 1, 5, 7, 4. Then there is another one. This is kind of old-ish chord progression. It's used to be in old music, and now it's not used very often. So like a 1, 7, 4, 5. So then you can do 1, 4, 5, 1, 4, 5, 1. So you can start with this thing and then play around with them. They kind of foolproof. You can play around with them, get some taste, and then start experimenting. I'm a person which is kind of afraid of ugly sounds, and this was a hard thing for me because some unpleasant note will just throw me off and I just cannot do anything after this. So I want to go like to safe approach and then start experimenting from safe, nice sounding things to more experimental stuff. But you might be different. You can just go full speed ahead and just start experimenting with the different types of chords.
So this is the chord progressions, and you can put like them. They can be one measure, two measures, they can be half a measure, so you can also experiment with timing when you want to switch them. There is a lot of talks about one more thing. It's called circle of fifth. It's not fitting too much into the what I'm talking, but there is a lot of buzz around circle of fifth, and it's basically like a theory of why music sounds pleasant and interesting, comparing with like why it doesn't sound pleasant. The idea of circle of fifth is we have 12 notes. Let's start from C. We have 12 notes. And we can put them in the circle, and we can go around the circle by fifth interval. From C to fifth interval, from C it's a G. Let me draw a keyboard. C, D, E, F, G, A, B. Fifth one, 1, 2, 3, 4, 5, and let's count semitones. So it's a 7, 1, 2, 3, 4, 5, 6, 7, right? So it's a G. Then we go from here 7 up, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. It's a D. So from D we go up 7, 1, 2, 3, 4, 5, 6, 7. It's A. From A we go up 7, 1, 2, 3, 4, 5, 6, 7. It's E. We go up from E7, 1, 2, 3, 4, 5, 6, 7, it's B. From B up to 7, 1, 2, 3, 4, 5, 6, 7, it's F sharp or G flat. From here we go 7, 1, 2, 3, 4, 5, 6, 7, it's C sharp or D flat. Going 7, 1, 2, 3, 4, 5, 6, 7, it's G sharp or A flat, D sharp, A sharp, F, or E flat, B flat. We have a circle of fifth, and we can see if we go on fifths, after 12 steps, we're returning back to C. This is kind of instrument for you how to around with the chord progressions. So you can just use existing chord progressions, but as you may notice, in the chord progressions, first, fifth, and fourth are kind of important chords in the key. And in the circle of fifth, you can notice F and G kind of close to C, C note or C key. What does it mean? It means they kind of related to each other. And if you see a circle of fifth, you can immediately know, like if you're in the key of A, you can immediately know E or D are important for A. And also it may help you to do key changes in the music, which add some character to your music, because like a music in one key is a little bit boring. Add some variety, and you can kind of understand to which key you want to change, so it would not sound very jarring. So like if you are in key of C, you can see here you can change to key of F or G or even D or A sharp to and it would not sound like a jarring to listeners. Or if you want to make it actually jarring, you can see switching to key of F sharp is really far away from key C, so it would sound like a more noticeable. So you can use this circle of fifth as the vehicle for your thinking about music and thinking in which key you want to go. I showed you can construct with circle of fifth by yourself just by counting up to 7 semitones. And yeah, it's the kind of theory behind is it's kind of simple, but because there is always different notes and you can construct stuff from all different keys, it's kind of hard to calculate. So basically you have to memorize a lot of things, but this is the foundation of how you can derive all this stuff without memorizing. But of course, like deriving takes some time. While you are playing around with the music, you can notice like this thing I'm using quite often, and your brain will because you're using this often, will memorize important stuff. And for example, for myself, I basically produce all music in the key of C, because like I memorized all these relations in the key of C, like F is 4th, G is 5th, and so on. So but just did my lazy approach, and essentially a lot of music doesn't matter in what key. It matters because like of vocal range, because of hardware limitations, but for listening it's not too much important in what kind of key your music is. And of course, like a transitioning from one piece to another piece would be more interesting. But anyway, so like then I'm producing music, I'm just sticking with C and just playing from C to our keys, but it's close to this part of the circle of fifth. I think this is quite condensed version of the music theory, and again I'm repeating, it's not the theory in terms of like how we engineers or like a scientist talking about theory. It's more about the language, and there is a lot of terminology here, names of note intervals, names of chords, triads, 7th notes, 9th notes, but it's all about terminology. And music is actually art, and you should not follow the rules, but knowing rules kind of help to understand where you are and help you navigate through your creative process.